All right. Good afternoon. This is Mr. Hicks. This is my first YouTube video. Today we're going to talk about multiplying polynomials. So first up, we're going to look at our first example here. I've got a quadratic monomial. I'm going to multiply it times our cubic trinomial here. To begin, we're going to just talk about we need to make sure that we distribute our term all the way through. I want to multiply our monomial times each of the terms in the trinomial, and using our exponent rules. So like our first up, we're going to multiply our 3x squared times our 4x cubed. So we're just going to multiply 3 times 4. That's going to give us our 12. And then we're going to multiply x squared times x to the third. So we're going to, since we're multiplying, we're just going to add exponents. So now we have x to the fifth. Now we've taken care of that first term. Now we're going to move on and multiply our second term in the trinomial. So I've got now 3x squared times this negative 6x squared. So now I'm going to multiply our coefficients. So I have 3 times negative 6 is going to be our negative 18. X squared times x squared. We're going to add exponents like we always do. So it's going to be x to the fourth. And now we have completed our second distribution within this term, or in this example here. And now we're going to finish up with our third multiplication here. We're going to multiply our 3x squared plus, or times this positive 7. So we're just multiplying coefficients. 3 times 7, we're going to get a positive 21. We have x squared, so we do have a 0 power here, but we don't really have to worry about it. All we have to do is basically transfer this and look at it as just, we now have x squared. We've now fully distributed or multiplied our monomial times our trinomial. We look for any like terms. In this case, everything is all simplified, so this is our simplified expression after we've multiplied all the way through and distributed our monomial into the trinomial. Next example up, we're going to look at multiplying a linear binomial times a linear binomial. Here it gets important that we are distributing both the 3x into the second binomial, but we also have to make sure that we distribute this constant 5 into both as well. So there's going to be 4 separate multiplications here. So I've got 3x times 2x, so I'm going to multiply coefficients. So I have 3 times 2 is 6. X to the first times x to the first is going to become x to the second. Again, so now we've taken care of that first multiplication. Our second multiplication is going to be this 3x times our negative 7. So 3 times negative 7 is going to give us negative 21. Just going to have x to the first. Now we're going to start with our constant 5 in this first binomial and distribute it into the second one. So that way we have all of our terms distributed. I have positive 5 times a positive 2x. So 2 times 5, we're going to have a positive 10. We got to remember that we have that x remaining, so I'm going to have x to the first. Now we're going to look at our fourth and final distribution or multiplication here. It's 5 times a negative 7. It's going to be a negative 35. So now we've distributed and done our multiplication here. Now we've got to go back and look and see if we have any like terms in our new expression here. I look through, I don't have any other x squareds, so that x squared is going to be left alone. But now I notice I have 2 terms that are in terms of an x to the first, or just an x. So we're going to look at combining these two here. So I'm just going to rewrite my x squared. If I look at negative 21 plus a positive 10, I'm going to be left with negative 11. We got to make sure we bring in our x, so I have that transferred down. And then our final term here, I don't have any other constants, so I'm just going to bring down our 35 and end up with our final simplified expression here. So I end up with 6x squared minus 11x minus 35. And now we'll look at our third and final example for multiplying polynomials today. And that will be this expression here, I'm going to have a linear binomial times a quadratic trinomial. So again, we always have to remember that we're distributing all the way through into every part of these polynomials. So I'm going to have to distribute the x to all of the three terms in the trinomial, and I'm also going to have to distribute the constant 2 into all of the three terms in the trinomial. So first up, I always like to go with the x because that's my first term in my binomial. So I have x to the first times x squared. So again, we're going to add exponents, so I have x to the third. Now we're moving from our first term in the trinomial to our second term. So I have x times negative 6x. So I'm going to it's going to be 1 times negative 6, or 6. X times x is going to be x squared. Now we're moving to our third and final one for our first term in the binomial. So x times negative 4, I'm going to have negative 4x. So now I'm going to move from my x term in the binomial and go to my constant term and start distributing that through my trinomial. I have 2 times x squared, so I have a positive 2x squared. Now I'm moving to our middle term here. Now I have 2 times a negative 6x, our constant, so 2 times negative 6 is going to give me 12, and we're going to have just an x here. Now our final multiplication is going to be 2 times our constant negative 4 in our trinomial, so I have negative 4 times 2, or negative 8. So now I've done all of my distributing. Now I've got to go back and start collecting and looking for all my like terms. I've only got this one x cubed, or x to the third, so I'm going to rewrite that down here so we can start collecting and simplifying our expression here. I have this negative 6x squared, and I've got this 2x squared here. So negative 6 plus a positive 2, we're going to end up with a negative 4x squared. Now again, I'm just going through and checking off whenever I have like terms. Like terms are when we have anything that are similar or the same, they have to be the same. So in this case, I've got a negative 4x here, and I've got a negative 12x here. When I collect those or combine those, I got a negative 4 plus a negative 12. I'm going to have a negative 16x. Finally, I'm going to look through and see if I have any constants or any other terms I haven't accounted for. The final one here is going to be our negative 8. So now I've got all of my like terms combined. I have a simplified expression. This is all I have to do in this case. So now we have our final solution. If you have any other questions, please consult us in class.